So next we want to talk about the software development lifecycle, which is also referred to as SDLC, so a bit of confusing there. Actually, they're very similar. I mean, if you have to really differentiate them, but I think the system development lifecycle are more well known, whereas the and it's more focused on operation and used by IT departments, whereas the software development lifecycle focus on design and programming and usually used by software developers, like application developers. Okay? Oop. Okay. And even the diagram is similar, but if you think of it as like you're building a software, you're developing a software, then the steps make better sense. So this is nothing to do with purchase. This is all just building your own software, like your own information system. So in this case, as I mentioned, mostly we're referring to business applications like online banking, like the shopping, like Amazon or Kijiji trading or anything similar to that. So you start out with requirements gathering. Okay, this is how I learned it when I was learning to be a programmer. So you start off uh, gathering requirements from the business as to what they really wanted to achieve, and then you start with all the requirements, and usually you ended up coming up with a business requirement document, and then you did the design. You start designing based on the requirement, and then you start developing it, and then after developing, obviously you testing and then you validate with the requirements and then you release and ongoing maintenance. Fairly straightforward and oftentimes we've taken it for granted. But if you're not familiar with code development or software development, that's what it is. And they're actually resembling the life cycle steps of the previous diagram of system development life cycle. Okay, but let's take a look and requirement gathering determine why, what, and for whom the software is built for what reason. Design is to deal with how to meet that purpose, like sometimes we call specification. Like at the end of the design phase, there should be a system specification document so they can define, maybe networking requirements, defining database requirement, maybe with designing data validations and so on. Okay. And then once you have all that nailed down, then you start coding. You start to develop and to meet the specification, and then testing, validation. I talk about it, and then release and maintenance. Straightforward. Um, from a project management point of view, like this, as you can see, the software DLC is a project. So you need project management. So good project management keeps the software development project moving in the right direction. So you don't spend too much time in design and never really get started with development, right? So project management processes are important to make sure that SDLT phases are executed properly. So if you leave the software DLC alone for the developer and development manager, it might not be wise because you need someone outside of the software development team, like a project management office, PMO, to really manage the project, keep the timeline and the resources. That way, the system will get completed. Otherwise, they will just keep, looping and never really get to complete it. Information security and risk management should be part of the project and be included in the project governance, control, and project business requirements phases. So in in big companies, when they do in-house software development, okay, and there's usually a separate PMO, project management office, and they will manage the project. And security usually is part of the gating. Okay, so we get involved by the project manager at different stage, and we perform our governance stuff, our control review, and so on. Okay, so let's take a look at the different steps. Okay, well, actually, requirement gathering, the security consideration in requirement gathering. We just want to talk a little bit about that. I mentioned right from the beginning that information security should not be in a software application or information systems should not be wait until the end or after the fact. Okay, so this is where it should happen first is the security requirements, security risk assessment, privacy risk assessments, risk level acceptance, all should be done at the relatively early in the project to make sure, you know, sure the business provided the business requirement. And security should be at the table in a sense that, okay, so if this is a business requirement, then you needed to actually include this security. So a good example would be this, the business requirement would be, okay, we need to collect customers' personal identifiable information, including their SIN number, for example. All right. If that is the case, then security would say, well, since you're dealing with PII, personal identifiable information, your information need to be encrypted in transit and at rest. So that's security requirement. And and for another example is that if that's not really quite clear, then a security risk assessment should flush that out. Similarly for privacy risk assessment. So if they wanted to have personal identifiable information, privacy risk assessment, which often not done by us, it will be done by probably privacy team. They will make sure that whether that's actually necessary, whether the collection is actually lawful, whether that's actually required or necessary. So things like that. Okay. Okay. So now at this point, we want to talk a little bit about correct processing of applications. Okay. This is a bit more technical, but it's also some common sense that you can appreciate how security should be built in. Input data control. Now, all user application almost always require input from either the user or from internal employees or some sort of a, well, user in general. It could be external or internal user. So data input to the application should be validated to make sure the data is correct and appropriate. I'll give you a good example. When you purchase something on the internet through, some, like using Amazon, right? At the end, you provide data, the credit card number. Okay, so they won't just take your word for it, right? So they take your credit card number. They have to make sure that credit card number is actually valid. Okay, and otherwise they won't be able to get money. Okay, so they don't, although they won't send you the product, but that would be a waste of their time, right? So data input meaning that you want to make sure whoever the customer enter the input, it is validated and correct and appropriate, and you can use it. Okay, so these are some of the implementation guideline. Checks should be applied to the input of business transaction, standing data like name, address, credit limits, and so on, and parameter table. So you wanted to, so for example, like nowadays, if you enter, a day of birth or some sort of a day, like, if you're traveling on Air Canada, they ask you for departure date and return date. They don't allow you to just enter the date mostly, right? They usually allow, they give you the calendar and you click from the calendar because that way it won't be wrong. You won't be entering like February 31st or something like that, right? If you just enter them, you still have to check it at the back end. So might as well use a calendar so that the user can only pick valid dates. So that would be a good example. So checking data validity should be checking like whether the value is our range. So if you only provide them to enter between 1 to 12, you should actually, you know, reject data that are outside of that range. Invalid character data field. So if you only if you're asking for the name, you should reject exclamation mark and so on. And any missing and incomplete data. So credit card number is a good example. Okay, credit card number usually is about 14 digits, and whether there's missing a digit and so on. Um, Exceeding upper and lower data volume. So if you do actually have upper and lower limit of the amount they enter, like a amount, for example, right? Like loan amount or something like that, or any other unauthorized or inconsistent control data. This is not our concern. This is not security's concern. I mean, this is more programming's concern. But we do need to understand this and be able to make sure that the developers include this validation. Okay. Review of the content, key value, insert hard copies. Sometimes you can allow the user to attach a document, okay, and you want to make sure you check you actually make sure the security requirement is that only non-executable are being attached. You know what is an executable, right? So file that can run can contain virus like exe, right? But so you want to make sure that when people upload something, the ending must be acceptable, like TXT, DOC, XLS, or maybe PDF. Okay, better. PDF is best because those are fixed text, right? So those are not something you can generate a virus or a macro. Okay. And also, if the programming is checking for validation of data, they should be routine for responding for validate invalid data. So what that means is that if you allow people to enter a range of amount they wanted to uh, maybe borrow a loan for a car, then you want to cap the limit about 30,000 or something like that. Okay, so if they enter something like 35,000, okay, rather than just clear the field and let them enter again, the people doesn't know what's going on. You should actually have an error message telling them amount exceed limit or something like that, so that the user know exactly what was wrong. All right, so that's all kind of common sense, I know, to most of us, but when we use the software, we never really thought of that. And actually, the more you use it now, you may have an appreciation that, oh, okay, this system is really not very good because it's not very informative. I don't really know what's going on. I mean, they keep rejecting me, but I don't know what I should be entering. So by learning through using it, then you know what is a better practice in terms of interacting with user. There's a term called user friendliness, meaning that it's user friendly. It's friendly for the user to use. So the user understand what is expected out of them. Creating a log of the activity involved in the data input process. So that way we know who used the system, who provided data, and what error has been made, and so on. Okay, there is definitely security risk via data input. Because automatic examination and validation of input data can be considered where applicable to reduce the risk of error to prevent standard attack, including buffer overflow or code injection. Now, in today's world, the hackers can manage to inject something on the input field on the website and put in a command so that when the application at the back end receive that, it become a command to force the application to execute a code. Okay, you may not understand this or fully appreciate this, but there are ways on the application code uh, accidentally take the input as an input for a command rather than for data. So the security risk is that we should reject any string of character that that's similar to a command that it will be execute, all right? Or to prevent anything going in being executable. Okay, and processing control, yeah. So you take the date range and so on. So you make sure that the coding has the checking for the validity of the input. Some other things are design and implementation of applications should make sure that the risk of processing failure leading to a loss of integrity are minimized. Remember, we talk about CIA, there's always integrity. So when the data are being entered into through the application, we have to make sure that data input are, um, the integrities are preserved. So credit card is a good example. If people enter a wrong credit card, you don't want to keep that in your customer record. Now, credit card is special in a sense that actually the string combination of the credit card contains something called a check digit. Okay, so the credit card embedded a check digit that will by itself, these combination, if people type transpose a 4 to a 5 or something like that, the credit card company actually knows that this should be rejected. Okay, so the credit card number is not serial, not like 001, 002, and so on. They actually padded a check digit number so that by entering the 14 digit, there's a certain combination that it is correct or incorrect. All right, so the credit card company knows. So when you receive that, you can quickly check with the customer or check with the Visa or whatever, and then you know whether it will reject or not, whether it's a valid number or not. Okay. The user of add, modify, and delete function to implement change to data. So if you allow through your user application that the user can add a record, modify, and delete, you make sure that those data are being validated because you're going to allow them to change the actual database now. This usually is not something customer facing, but still, this is part of coding. The use of appropriate program to recover from failure to ensure correct processing of data. So when you receive something, if it's wrong, then you either reject them or retain the old data. So if you allow people to modify and then you check that the data is actually wrong, then you reject them, you still keep the old version of the data, and then you put it back, or you never really change the original data until it's validated. Or sometimes it actually uh, after check. So when someone is online modifying something, it won't actually get saved to the database until overnight or until a double check over batch or something like that. Okay. So there are ways to make sure that if that you are allowing modification directly to a book of record type of information, you want to double check and double sure the integrities is accurate. Okay. Okay, I think we talk about control check. Control check is kind of like, when you enter, like in a spreadsheet, right? You just think of that. I'm not saying that the application is like in a spreadsheet. So you have different, like the amount of time you spend on different projects. So you calculate the control total, and then you calculate across Monday, Tuesday, like a timesheet, right? Monday, Tuesday, Wednesday, and Friday, you add it across. So the the consumption over the week for all the 3 or 4 projects, the control total and the day total should add up the same. So if I spend 5 hours supporting 3 projects in Monday, 4 hours in Tuesday, and so on, I add it up at the bottom of all the day total should equal to the project total over the week. That's called control check. Okay, so you apply some sort of ways to check the numbering so that it actually lines up. Okay, that's again making sure that the data you collect have the integrity. Okay, again, always create a log of activities so that you can trace back what actually happened. Okay, message integrity. Requirements for making sure authenticities and protecting message integrity in application should be identify, appropriate control, identify and implement. So one of the things is cryptographic technique can be used as an appropriate means of implementing message authentication. So nobody can actually change the content of the message. Okay. Output data validation, data output from an application. So this is like maybe a report, maybe a balance display, should be validated to make sure that the processing of store information is correct and appropriate to the circumstances. So you wanted to double check whether what the user retrieve is what you are about to present to them. Okay. So output validation should have quality check, reconcile control count, as I mentioned about the across and a vertical value, uh, procedures for responding to output validation tests. So if the output doesn't really validate, then you don't display and then you produce some message for the user. Again, create a log of activities in data output validation process so that we always know, what's going on, what went wrong, who did what, and so on. Okay. Typical consideration would be system and application are constructed on the assumption that having undertaken appropriate validation, verification, testing, and output will always be correct. Okay, so making if the input is always validated and the modification is always control and the removal, deletion is always control and authorize, that way the output can be more reliable because you are stopping all the bad input that will jeopardize integrity, then the output can be more reliable. Okay. Now this is the assumption, but the assumption may not be always valid. There are systems that has been tested may still produce incorrect output. So you want to be able to test the output at the point of display, right? So there are depending on circumstances. Again, if you design the system from beginning to the end, or what we call end-to-end design, and security consideration are imposed from beginning to the end, then you feel more certain that the information is consistent and and has its integrity all through the system from beginning to the end. Okay. Okay. Now we come to some of the what we call extra information. We talk about security architecture, which I mentioned at the very beginning that may or may not be interest to many of you. So I'm going to treat these as extra information, and I am not going to dive deeper. I'm just going to kind of skim through this. So security architecture is one component of the overall system architecture in and is developed to provide guidance during design of system. Normally, when you design a system, like a normal information system, you had a system architecture as to what network it should use, how data should be checking or input or output, and so on. But security architecture kind of overlay onto that. So some of the security architecture would be PII, personal identifiable information, need to be encrypted at rest and in transition. Okay, so that's security architect, right? Or external communication with vendors sharing sensitive information need to be in an encrypted tunnel, something like that. So that's security architecture. Okay, these are not policies; these are guidelines. These are requirements and specification provided for the system development lifecycle people and the software development lifecycle. Okay, so that they know when they are designing something, these are the security requirements. So in short, security architecture is a structural set of security requirement in building an information system, basically. Okay, so there are obviously areas as accountability, avoid security obscurity, compartmentalization, compliance, defense in depth, encourage reuse, fail securely, least privilege, protect the data, reluctance to trust, secure by design, secure by default, separation of duties, separation of management services, and simplicity. Some of these we talked about already, right? Remember number 8, least privilege? We talked about that in the first lesson. We talk about separation of duties, separation of management service. Okay, we also talk about that. Defense in depth is like layer of defense, right? So we talk about that a little bit. So there are a lot of information in the subsequent slide, and I'm not gonna go through all of them. I'm gonna just pick some of them. I think number 2, avoid security by obscurity. This is a bit of an old school. Maybe you think like that too. Is that oftentimes we think by protecting security, we try to hide things secretly. Okay, so meaning that if I'm not telling you anything and I try to hide it, that will provide security. I think it's true to some sense, but do not only rely on secrecy and complexity. So a simple way of 1, 2, 3, you just make it more difficult to find out the right way. But the problem is these secrecy and complexity can backfire. Okay, if that's the only method of providing security to a system, then it will backfire. All right, use standard cryptography, which it's a well-publicized algorithm and so on, rather than using some obscure way to kind of maybe just secrecy and complexity. Okay, so and number 5, defense in depth. Okay, redundant and layer security. I talk about layer of security. Remember in the physical security class. So defense in depth is similar to that, meaning that we need to redundant security. We also need to layer security to protect the company solution, system, and asset. So an example would be a solution architect that use physical and virtual firewall, direct networking, and IP restriction on individual servers. So multiple things. You use multiple layer of security. Okay. Okay. Number 7, fail securely. Information technology and solution architects should maintain confidentiality and integrity in the event of loss of availability. So when availability is lost, you lock it down, okay, so that it will fail securely, so it will not fail open. Unlike fire and personal safety, when there's an alarm, you open the door for people to evacuate. But in a information system, when there's danger, you close it up, you lock it down rather than wide open for people to use it. You lock it down. So that's fail securely. Least privilege, you talk about reluctant to trust. The company's information technology and solution should be reluctant to trust any connection, any interaction with user data and systems. So by default, when I talk about this, remember we talk about suspicious mind, right? So we wanted to have a mind that is suspicious. Okay. I mean, from an information security level. So reluctant to trust is the same. We don't want to trust you unless you prove that you are who you say you are, right? Okay, so I think, um, yeah, number 15 is kind of, you know, in response to the complexity and security, right? In obscurity, right? Where there is a choice between complexity and simplicity in manifestation of security, when the level of protection and controls are the same, then simplicity must be the choice. The simplicity is simply simple to understand and implement, so that people down the road, because you will never be the only person that manage this. You'll pass it on. You'll pass it along to the next generation, the next user. You will leave the company, right? So the simpler solution is easier to make the next person understand. Okay, so that's it. And the tip of the day is about application security countermeasure. So we're talking about include security requirement during the system design, not after the fact. I'm just kind of like a conclusion, repeating some of the things we talk about. And this is important for you to kind of appreciate, right? So conduct proper risk and security assessment in order to establish security requirement and control for application. So you need to develop solution, like always, develop security solutions that are risk based. Okay. Security scanning for programs. So we're talking about programs out there, third-party programs that will help to scan your code and find vulnerabilities. Okay, the way how codes are written and so on. So there are some helps out there that help through developments. Okay, so do that. Okay, there are services that you can subscribe to, upload your code, they'll scan them, then give you a report that pinpoint area that you should be paying attention to or change the code. Conduct penetration testing to all in internet customer facing applications. If you don't know what penetration testing meaning, these are ethical hacking. So these are people that you hire uh, to pretend they are bad guys and try to hack your information systems from the internet before you actually release it to the public. So they try to do bad thing, in SQL injection to some of the code and so on, and try to see how bad what they can do and how bad they can make your system and penetrate through, right? So if you are developing any critical application or important application that are facing for the customer on the internet, you need to do penetration testing before you release it and go production. Penetration testing will be able to identify some of the common vulnerability that you may missed, even though you do code scanning. Okay, and in any big company, bank especially, that money is transactions, then almost all of the internet-facing applications are penetration testing every year. Okay. Apply risk management pertaining to identify risk in the application before go live. I mean, it's like, because going live meaning that you're making the application available to the internet, which is not only your customer have access, is everybody have access, including the bad guys, day and night, 24/7. So they can have all the time they want. Unlike in the movies, when the bad guys wanted to kind of get through the vault of a bank, they have to wait until dark, and they drill through the wall in the basement and so on. And so it's only a window of time that the alarm is not on. But for a internet facing application, it is available for the bad guys 24/7, 365 days a year. Okay, so you want to make sure that your outward facing application is secure. Okay, so that's it, and that's the end of this lesson. Yep. Okay, thank you for watching. Okay.